Angle similarity. Determine the triangles are similar by angle similarity. Be quiet, Jayla, and pay attention. You're already on video. Look at that. On this first one, you got a small triangle connected to a larger triangle. We're trying to prove these similar by angle similarity. We can't just say that it is. You have to prove it. And so once we prove it, we're either going to say yes or no. It might be a no, it might be a yes. On this one, though, things you should know. Let's start with what you should know. Based on the way these triangles are connected, what should you know? And we'll say it a little louder, Ralph. You should know that these vertical angles in the middle here are congruent, yes? You should know that automatically. Then the other piece of information that you should use is the fact that they give you these arrows here. They're parallel. Now, let's see if y'all remember. Only a couple kids remember today. Whenever we talk about parallel lines or parallel sides in these kind of triangles, what angle relationships are we looking for? It's two of them. Go ahead, Dakar. Corresponding. I'm proud of you, son. You've redeemed yourself for the day. Either looking at corresponding angles or alternate interior angles. Alright? In this case, once we mark, you should know which ones they are. In this one, I know that this angle up here and this angle down here are congruent because of the parallel lines. These are which ones? I'm asking. Corresponding or alternate interior? Alternate interior. Y'all should all recognize that. Shh. Alright. At this point, do I have angle similarity? I'll say right yes. You wouldn't even have to go further. Even though on this one, since they told you parallel, you could show that these angles and these angles are congruent too. But you only need angle for similarity. So this is a yes. These triangles are similar. Alright, slide no. Pay attention. Stop talking so much. Number 2. On this one, they want to prove that these two triangles are similar. Don't necessarily know. You can need to check. They gave me 90 and 39 on one, and they gave me 90 and 51 on the other. Quickest way to check on this one is to figure out what angle S is. What's angle S? How would I find it? Somebody tell me that math real quick. Somebody tell me the math. Some people don't know. What's up? 90 plus 39. Yeah, so 180 minus that. 90 plus 39 is going to be 129. $51. So 51 degrees in here. So I ask you now, are these triangles similar by angle similarity? Alright. Do number 3. Tell me what's up. What's angle B, Dakar?
Oh.
Taking all day. We'll come back. Okay. 58 degrees. I mean, at that point, you wouldn't have to find angle E, but if you found angle E, y'all can give it to me. Anybody found angle E? 49. Okay. So just by saying that, what's up? No. This is when this would be a no. So honestly, even better than no, you would say not similar. I'm gonna just use the symbol, not similar. Sliding over. This one I want to talk through with you. On this one, oh, go ahead. You can tell me then.
Like the vertical angle touch
Parallel. What?
Not parallel, but it's like.
You know what? So they've been naming them for me. Name the two vertical angles using 3 letters.
YXZ and
Good. Thank you, sir. I heard you. QXP. Okay. Yeah, those are my two vertical angles right there. They already told you that P and Z were congruent on this one, so I mean, all you had to do was put your verticals in. Then you're good on this one. This is a yes. Now, like I was telling the kids in the other class, we don't show y'all one on here, but you need to understand, you can't assume anything. In this one, they told us P and Z were congruent. In that very first one, they told us that those two sides were parallel to each other. The thing you need to understand is they don't say either one of those things and the figure is completely blank and all you can put in is vertical angles. You can't assume that you got alternate interior angles unless they tell you parallel. Or you can't assume that the angles are congruent unless they mark them congruent like they did on this one. So if they don't do either of those things and they just show you a blank triangle with connection in the middle, only thing you can assume is the vertical angles because you know they share those. And if that's the case, then you can't prove angle-angle similarity if that's all the information they give you. I want you to know that because I feel like in the past on the test we've asked one like that. But the whole figure was blank and all you could do was put in vertical angles. And some kids will still say angle-angle. Angle-angle is not true on that. If the only angle you can give is the vertical angles, then that's not showing similarity. They have to give you something else. Like I said, on the first one they told you the lines were parallel. On this one they gave you that these two angles were congruent. So that's why we were able to do it. Alright, sliding on. So that's angle-angle similarity. Next one, side-side-side similarity. This one has a little bit more entailed into it. Side-side-side and side-angle-side. You cannot just sit here and assume that these triangles are similar just because they got something on each side. That's not how side-side-side similarity works. And let me ask this question. This is going bad all day too, but hopefully it goes better in here. Let me pose this question to you because I talked about this at the beginning of this unit. We talked about the difference between congruency and similarity. In this case, we're looking at similarity. For these sides, if I was to match these sides up, how would I know that they're similar? Sides of similar figures have to be what? What's the word? It's in your notes, but it's in the very first set of notes, similar figures. Similar figures. And if you're behind, don't know, you might want to go look again. Similar figures. I said, how would you know that the sides are similar on a pair of figures like this? They would have to be what? Same. Similar. If you're saying the same, then that means they're congruent. We're not dealing with congruent triangles. Send the first set of notes. Similar figures. The first set of notes for this unit, DJ. Similar figures. I need you to look at it anyway because I'm about to talk about this again because I'm mad that y'all don't know. I get it's been 2 weeks, but Jesus.
Wait, what did you say? What was the question?
What needs to be true about the sides if two figures are going to be similar? Maxim, what's up? Thank you. Been waiting on that word for about 3 minutes now. Say it one time, Maxim. Proportional.
Oh, yeah.
Oh, you tripping. That mean you ain't write your notes good. Don't make me pull mine out. We wrote 2 sentences, and it's right in the middle of your notes.
Oh, I see. Oh, proportional. Never mind.
So, since y'all at it, let's go ahead and read the first sentence on that too. What about the angles?
Corresponding angles are congruent.
Corresponding sides need to be proportional. That needs to be true about similar figures. So you can't just sit here and look at it and say, yeah, these are similar. You need to prove the sides to be proportional. To prove that, they should all reduce down to the same ratio. But the thing about it is you don't want to sit here and waste your time reducing these down, especially if you have ones with decimals in them like this. It's going to take, and it's hard to reduce that. Honestly, some of these can't even be reduced. To see if they have the same ratio, there's an easy way to do it though. Let me show you. First, you need to make sure you set up your sides correctly. Doing this is easy, but some of y'all gonna mess this up because y'all just visually, I don't know, something's wrong. I told you I read my stuff left to right every time. That's just how I do, unless it's stacked on top of each other. In this case, reading left to right. Oh, Jesus. Let her in, please. Now, I'm not worried about the naming of the triangles. Shh, just listen right now. Because the statements aren't given for you anyway, so that's not going to help you. Alright.
Let's get this one.
Back to what I was saying. Shh. On this, to match up your sides, they don't name it, the figures for you, so it's gonna be hard to do it that way. Jayla, get yourself together. They don't name them for you, so you can't do it that way. The best way to do this is match up small side with small side, medium side with medium side on the triangles, and then larger side with the larger side. It's really not that hard to do. So if I'm reading left to right, my smallest side on my small triangle is 5. I'm doing 5 over what on the other triangle? 18, thank you. And then the next one, I'm doing 12 over 43.2. And then the next ratio I'm writing is 15 over 54. If you don't have a calculator, you don't need one. Or you could just use your phone, however you want to play it. Yes. Here, like I said, reducing is going to take forever, and it's hard to reduce. You're going to have to get all those to go down to 5 over 18, because you can't reduce 5 over 18. And I don't know how you would reduce that to get to 5 over 18. To check this, quickest way to do it is just to divide. First thing I'm going to do 5 divided by 12. I mean, not 12, excuse me. My bad. I'm tripping. 5 divided by 18. Let's try this again. 5 divided by 18. That is not the decimal. There it is.
Thank you.
This is a long decimal. I'm not about to write the whole thing. I'm just about to write enough so I can see it on paper. It's kind of like a repeating 7. Yeah. No, don't round nothing. 12 divided by 43.2. Get the same thing. So good so far. You need to check all 3 sides though, because one side could be different. If you round too early, say DJ, if you round to 0.3, and then you calculate your next one, and it's 0.3 exactly. Those are not similar. You just made them similar for yourself. You see what I'm saying? They have to be exact to be similar. Exactly. They all have to be the exact same decimal. If you start rounding too early, you're going to mess yourself up. You shouldn't round anything. I'm giving you the quick way. I'm letting you use decimals. Alright, you get the same decimal for all of them, so the question is, are these triangles similar? Yes. By side, similarity. All the sides are proportional. They're all proportional, then they have to be similar. Now on this next one. Same thing. The only thing that might be trouble for some of y'all is the fact that these are stacked on top of each other. So what we definitely, I didn't give them a choice in third period, but second period I gave them a choice. I don't know, third period was acting real crazy, so they couldn't get no choice. But the best thing for you to do on this, to make sure you see the numbers correctly, is to redraw these triangles separated from each other and then label them. Let me show you what I'm talking about. And they don't have to be big out to the side. Just redraw the triangles. Like I'm going to do the small one first. Ain't got to be nothing big or spectacular. Just draw that triangle, then I'm going to do the other one. A little bit bigger than it. And then the first one I'm going to call it W, V, X. Second one I'm going to call it W, U, Y. And then I'm going to label them. On the first one, WX is 15, WV is 20, and then VX is 40. On the second triangle, what's WY, DJ? Thank you. That's the reason I make y'all rewrite them, because some kids mess up on this part right here. WV. It don't matter. WU, excuse me. I'm sorry. Thank you for correcting me. You know what I meant. And then 56 for UI. Alright. Just splitting it helps y'all see the numbers better. And then after that, you can write your ratios for me. Smallest to largest. 15 over 21. Then 20 over 28. And then the last one will be 40 over 50. And then you need to check and see if they all the same thing. So you get this decimals, a funky decimals, 0.7142, whatever. Let me just write the first couple of numbers. 0.7142. Honestly, man, you'll remember what you see in the calculator. If you get to this point, like you write 5 numbers down and it's the same decimal, it ain't gonna change. Like it'll be obvious if they're different. Like it'll be like 0.71 and the next one might be 0.75 or something like that. It'll change very quickly, the numbers. They won't be that close. It won't ever be nothing that accurate where it's like 5 numbers in and then the number changes. Yeah. So you ain't got to go too hard with it. Yeah, and so if you calculate all three, you're going to get the same thing on all three, which means this is side similarity. So this is a yes. Same thing on number 7, but I want y'all to do that one. Number 7, split it if you need to. If you feel confident without splitting, you don't have to. But if you need to, do what I just did on the last one. Split the triangles, label them, and then set up my ratios and tell me. I know you're probably ahead, but we got to wait. Oh, you had a question on the last one? What's up?
Well, instead of dividing 15 by 21, I divided 21 by
It ain't going to change nothing.
I'm just saying that this is what I said.
Yeah.
Because I got a way smaller decimal.
Yeah, that's because you did a larger number of smaller. It won't always be a smaller decimal. In that case, it will. I mean, it just did work that way. But yeah, what she's saying is she set her larger numbers up on top of her smaller number. It's going to be the same thing. You're just going to get the same decimal every time. As long as you set them up correctly. Yeah. Yeah. Whichever way you find better for yourself, I can't suggest that for you. I just read stuff left to right. So however I set up left to right, that's what I set up. You feel me? But it ain't going to matter. You're going to get the same decimal either way. It's just that if you put the bigger number on top, you're going to get a number greater than 1. And it may be a smaller decimal, it may not be. Like it's one that we'll do in a second. It ain't going to matter which way, it's going to be a long decimal. It might even be this one. Let me see. I can tell you right now. I know what the setup is. Yeah. If this next one, no matter which way you do it, you're going to get a long decimal. Huh? Yeah. You see it on this next one, don't you? Uh-huh. I'm not going to split my triangles, but like I said, if you feel comfortable doing that, do that for yourself. I just want to see what the ratios y'all wrote. Eric, you wrote your ratios yet? Huh? You was talking, I thought you did. You wrote... Yeah, you can. But it just makes you match up still. Smallest number on that triangle, the smallest number on the other one. The smallest, middle, then largest. I don't want to go to DJ for everything. Somebody else got ratios? I just want to know the ratios right now, bro. Huh? Okay, that's where you start there. Okay. So you got... Well, let's go smallest first. I want to go in order. That ain't it. 6 over 16. 6 over 16. Then he said 8 over 20, which is correct. And 9 over 24. These are the three ratios you should have wrote. Now you either wrote them whether your biggest number, the smallest number on top like we did, or you got them flipped. You either got that or you got 16 over 6, 20 over 8, and 24 over 9, which is fine too. And like you said, if you calculate this correctly, you should see that everything is not going to come out the same. 6 divided by 16 is 0.375. Actually, on this one, it works out while your decimals look better when you hear me? Your decimals look better on this one when you do the smaller number on top. I don't know if you saw that. Since I'm saying that's why I don't know. It's either way. Because this decimal is cleaner than going the other way. 16 divided by 6. And on this one, 0.04. 0.4. I said that wrong. Then the last one, 9 divided by 24. Same thing as the other one. And DJ realized very quickly why I told him not to round. If you do, you're going to throw yourself off. You said that mess right around that first one is 0.4. Look at your second one. Do not round these. So, not similar. And then obviously y'all can check number 8 on your own. Handle that. Oh man, let me get this on video. Number 8, y'all decided was not similar, which was good. Alright. Last one, side angle side. On this one, concept isn't much different than what you just did on the last one. Only thing you need to understand is side angle side similarity now. So on this one, with side angle side, it's just two sides you're looking at to see if they're proportional. Then you got to make sure you have an angle in the middle of those two sides. So before I would even work these out, I would make sure I got an angle in the middle. On these two sides right here that they're showing you, on these two figures, you should see that you got the vertical angles here in the middle. So that I just said that, literally just said that. So if that's the case, it qualifies for side angle side. You just got to make sure it is a yes or a no. So you need to check. So I'm matching up. Now I told you I usually go left to right, but since these are stacked on top of each other, I'll probably do my smaller triangle over my larger one. So I would match up my 6 over 24. And then I will match up my 12 over 48. Now it's up to you if you want to do 24 over 6 and 48 over 12. That's very up to you. Doing it this way on mine, 6 divided by 24 is going to be 0.25. 12 divided by 48 is going to also be 0.25. This is going to be a yes. This is side angle side similarity. It's very quick checks that y'all need to do, but y'all need to do it because it's not always going to be a yes. You can't sit there and assume. 10. Looking at this one, it qualifies. You got a side and a side, you got an angle in the middle here that's congruent. Same thing on this one, side and a side, an angle here in the middle that's congruent. And they tell you that these two angles are congruent to each other. So you need to check and see if the sides are proportional. If that's the case, then this is side angle side similarity. So set up your ratios and check real quick. What you said? You said this one number 10? That's what I got. Huh? Oh my.
You said no? You said no?
Your brother got no too. Jayla, what ratios you wrote? Help me out. Yeah. Okay. Shh. Quiet. Can't hear.
And I got 31.5 over 45.
Okay.
And they both equal 0.7.
Well, this is the way she wrote hers. I ain't gonna argue with her though.
I got what they got.
She wrote these two ratios, which are not wrong. I mean, she just went largest against largest, and she went this way, and then she went smallest against smallest. It ain't gonna really change now. Your decimals should still come out the way they should come out. Like for her, so she did it this way. It's gonna be 35 divided by 50, which is gonna give her 0.7. Is that what you got? 0.7, and then 31.5 divided by 45.7. I know, it's okay if you do it that way. So she got 0.7 for both of hers, but this is how I've been doing it all day. Some of y'all might have did it like me. I did 45 over 31.5 and then 50 over 35. I still got the same two decimals, same two numbers. 1.428, 1.428. Still the same thing, still a yes for me. It don't matter if you put the smaller numbers on top. I mean, it don't matter which way you go. As long as you set the ratios up right, you should come out right. So this is a yes. Alright. Some of y'all might have jumped ahead of me and tried to do number 11. That's on you. Should have waited. Number 11. On this one, I told you, first thing you need to check in is that you can even prove side angle side similarity. On this one, only thing I know based off what they give me on this figure is that my vertical angles are congruent. So though these two angles right here are congruent, I can't assume any other angles are congruent. Based on that, can I even prove side angle side similarity on this? How does this read? Angle what? Angle side side. Y'all know what that is. You want to say it on video? Yeah. For you to even be able to prove side angle side similarity, it has to be a side here, angle in the middle, then another side here. Or, I mean, if they gave you angle J and angle Y, yeah, maybe you could do a side angle side similarity on this one. But you don't know that angle J and Y are congruent, and they didn't tell you enough information to assume that. This is one of the ones that I tell you can't assume. They didn't put parallel on here, and they didn't even mark these two angles congruent. So you can't assume those two are congruent. They have to give you something for you to know that they're congruent. What?
What's different from that?
Side angle side. You follow? So on this one, not similar. And you can write Y on there. I ain't gonna write it on screen. But you could put the ASS on there. Sliding over. So this one, same thing. You got to decide first, can you even prove side angle side congruency? Huh? On number 12 either? Where these two triangles share? Huh? Thank you. These two triangles share a W right here at the top. So I ask you again, can you prove side angle side congruency on this? Alrighty. Set up and prove it. You might want to split again. You might want to split your triangles if you one of those people who have a hard time seeing them put together like this. You might want to redraw both of them separate. You can. If you're not one of those people that have a hard time, then make the adjustments and write the right numbers then. Hold on, we gonna hang in there though.
Hold on, what?
She say she's sleeping. Hold on, give me my ratios, Robert. Shh. Hold on, y'all be quiet. I can't hear. Robert, go ahead.
42/14.
Do it the other way, man.
14/42.
Thank you. I like that.
I got 14/45.
Thank you. Shh. Your ratio should look something like that, but Robert did his bigger than on top, which is fine, but I think most of y'all gonna do like me and do the smaller than on top. Yeah. There you go. Somebody asked a question. What? Ask it out loud if you don't understand something. You good? Okay. 0.3333, like she said, repeating. Then the other one was the same. 0.333, repeating. So, you asking yourself, are these similar? Yes, they are. You shouldn't have did 15/42. Why did you do 15/42? No. I said if you do the larger number on top, if you do 42/14 or 45 or 40 over 15, yeah. And honestly, you probably got 3 for both of yours, right, Robert? Which is correct. We getting point 3333 read it because that's the fraction 1/3, which is the reciprocal of 3. Can you feel me? That's why we getting that decimal.
I did 15/14. And then 14/20.
Whole thing. You can probably get away with it on this one because of the side splitter. You probably still get the same decimals you did. You'll get away with it because of the sides. But if you do that and then you compare it to the one, that bottom side, QR and SZ, that's where you're going to mess up. Because you're doing a section over a section and not a section over the whole thing. If you follow what I'm saying. Like when you get to this bottom side, it's QR is the whole piece and SZ is the whole piece. If you set that up with those two like that, you're going to mess yourself up. If it was side, then you had to check that. So you would want to do this piece over this whole side. Alright. 13 through 16 is for y'all. Let me explain what you need to do though. On these, you got to make the decision for yourself. The first decision you should make when you're looking at it is like, which one am I actually even solving to see if I'm proving? You could do that just by looking. Is it going to be angle? Is it going to be side, angle, side? Or is it side? Then after that, prove if they're similar or not. If they are, then tell which way they're similar. Which one of the 3? Angle, side, angle, side, or SSS. And if they are similar by one of those similarities, the next thing you need to do is write the similarity statement. And y'all should already know how to do that. I haven't had to explain that to anybody today because y'all should be used to writing congruency statements and similarity statements by now. The first question I got for you though, Deja, since you on today, number 13. Just by looking at this one, which similarity would you be trying to prove? Deja, nobody else. Just by looking at it, which similarity am I trying to prove on this one? Out of the 3.
Wait.
Oh wait. Yeah. Wait, I'm confused. Oh, similar.
Trenton, go ahead, take over. What?
It's side, angle, side.
Side angle side.
Go ahead.
I said it already.
I know, say it again. It ain't.
Oh, side, angle, side.
Side angle side, but why? Somebody explain why.
Because.
Oh, I see that. Oh, I see that angle.
You got the one side. You got the middle. I did not see that.
Alright, that's what I'm saying. I'm gonna need y'all to use some common sense when y'all doing this.
I did not see that.
No. I'm just asking you which similarity would you be trying to prove anyway.
Shit.
Just by looking at it, you can tell that. I hopefully we didn't catch that on video.
That was a lot.
But listen, they give you 2 sides and an angle in between. This has to be side angle side similarity that you're trying to prove on this one. So the thing is, you need to check it to see if the sides are proportional. If they are, Then write side angle, side similarity over there, and then give me my statement. If not, just say not similar and keep it moving. Handle your business. Do those four real quick. Alright. If triangle CDE is similar to triangle EDF, they gave you similarity statements on here. If they give you a similarity statement, use it. It says find the value of X. On this one, they give me similarity statements. They're telling me how I can write my proportions. So I'm going to just match up the way they're telling me. On this one, ED, and I'm going top to bottom. So ED, I'm looking at ED, and this ED is right here. ED matches up with what? CD. So I'm going to write that over that. I'm going to do 5X minus 2 over 48. And then after that, DF matches up with DG. So 2X plus 7 over 40. This is the proportion you should write. Cross. Once you cross, you should realize that you got to distribute. So I'm going to rewrite this so I can see my distribution clearly. 40 parentheses 5X minus 2 equals 48 parentheses 2X plus 7. Then I need to distribute here and here. Rewrite my equation. 40 times 5X is 200X. 40 times negative 2 is negative 80. 48 times 2X, 96X. 48 times 7, I think they told me 336 earlier. I'm going to roll with that. And then from there, if you can make it to this point, it's just equation with variables on both sides. You need to get variable on one side first. I always move my smaller one. Been telling y'all that since the first day y'all met me. Cancel. 104x. Bring down 80 equals. Bring down 336. Add 80. Add 80. 416. 104x divide by 104. X equals 4. Alright, y'all gonna see problems like that. Y'all need to be able to solve the proportion ones. You need to be able to set them up and solve. Last thing, and I'm gonna flow quick with this. Proofs. So this is what the stuff y'all was doing is building up to. For you to be able to do similarity proofs. These are not congruency proofs, these are similarity proofs. They kind of flow the same way though. Same kind of content, just similar triangles now. So at the end, when you get to the point where a triangle is similar to a triangle, that's where you want to tell me one of the similarities. And if they ask you to go further than that, then you're going to be talking about corresponding parts. I'm doing number 3 first. Y'all should be able to flow on this one with me. Let's, what discussion do I need to have with y'all first? No, I don't need to have one. We can roll. Okay, it says given on number 3. It says TE over TA is equal to TS over TM. So this is the first thing that looks different from the ones y'all been used to before. This given information looks different. But think about what kind of proof you're doing and you understand what they're telling you. These are similarity proofs. They're telling you, they just gave you a proportion right there. But look at the proportion they gave you. They told you TE over TA was equal to TS over TM. How do they know that? They're telling you the sides are proportional. That check that we've been doing this whole class period, they're telling you that off bat. They're telling you these sides will reduce down to be the same ratio. If that's the case, then I know these sides are proportional. Now, there's no way I can mark off proportionality on a figure. We only ever mark off congruency or parallel lines or whatnot. So I was sitting there thinking about it. But a girl, she said something good in second period. She's like, let's just put a P on all of them. I agree with her. Yeah, Let's put a P on all these sides showing that they're proportional to each other. At least we'll know. We just need to know it when we get ready to call out our stuff. You do whatever you want, DJ. Stop asking me questions, man. Just listen. Decide what you want to do for yourself. You get them wrong, I don't care no more. Stop asking me so much stuff that you don't need to ask me. You're on my nerves now, dog. On video. I don't care.
But come on, like for real. You're not gonna be sitting by me arguing with the teacher. Sorry.
You gotta make me pause this video and yell at you. I'm gonna keep going. It is given. What's given? What's the letter y'all choosing? Just tell me what letter. Yeah. C. Then after that it says the reflexive property states that value is equal to itself. Therefore, my question to you on this one though, what's reflexive about this image? What does these two triangles share? T, but T ain't gonna be an option down here. Y'all gotta be specific. They want you to name it correctly. Which one of these is the correct name of angle T? Which one y'all see? I, yeah. ETS is congruent. Angle ETS is congruent to angle ATM. That is the exact right choice for this one. I. And we can mark that off on here. So they're showing congruency between those two angles. They share it. So this is I. Then it says due to the blank similarity postulate, we can state. So let's, at this point, this is where we want to name the similarity postulate. Based on what we've shown on the graph, which similarity are we proving here? Which letter? H. Thank you. Side angle side similarity. Thank you for those who've been paying attention. Then from there, since it's side angle side similarity, we can state that these triangles are similar. Name the two similar triangles. You got a couple choices there. Which one is the right choice for the similar triangles? It is B. TSE, triangle TSE, is similar to triangle TMA. Y'all see that? Alright. So that's B. And then after that, so now at that point we've proved the triangle similar to each other. On this proof though, they wanted us to take a step further. They wanted us to prove that angle TSE was congruent to angle TMA. I should have marked those earlier, but I'll mark them now. Angle TSE is congruent to angle TMA. Now that we know the triangles are similar, we know all the angles are congruent. But we need to tell why these two angles, TSE is congruent to TMA. Because of what? What's a good reason for that? Knowing what these two angles are. I heard D, I heard M, and now I just heard K. Let's read all three and let's find out which one fits us best. D, corresponding angles of parallel lines are congruent. Did they say anything about parallel lines in here? No. So we can't assume that any lines are parallel. M, corresponding sides of similar triangles are proportional. These two angles that I marked, are they sides at all? So that don't make sense. K, corresponding angles of similar triangles are congruent. What did we just prove? That the triangles were what? Similar, right? So they asking you, how do you know these two angles are congruent? They're corresponding angles of similar triangles. They are congruent. So this is K. Alright. Number 6. This is the last one I'm doing. You have to do the other two. Number 6 says given segment AE is parallel to segment BD. We don't need to mark that off because they already got the parallel arrows on there for us. But we go back to Descartes because he said it earlier for us. Descartes, they started out by talking parallel. So at some point in this proof, what you think you're going to mention? Which kind of angles?
Corresponding
Or?
interior or exterior.
Yeah, corresponding or alternate interior. Alright. So let's look at it. It says since. Oh, and on this one we're just trying to prove the triangle is similar. So once we get to the end, that'll be our similarity statement. Faith.
What?
The music.
Oh, it's loud. My bad.
Y'all tripping today, man. Since it is blank that segment A is parallel to segment BD, what's missing? What is this? F, thank you. Given. We can say that angle CBD is congruent to angle CAE. Now, y'all dealt with me long enough with these proofs. Before you sit here and try to write any silly little answer in on this blank right here, what should you do since they call two angles congruent? Mark them on the triangle so you can see them. They said angle CBD was congruent to angle CAE. Once you do that, it really informs you on what you're looking at. How do you know those two angles are congruent since they call these parallel lines? Due to what? Due to A. Corresponding angles of parallel lines cut by a transversal are congruent. Next it says due to the reflexive property, we can state that. What somebody said? I can't hear you. Said D?
E.
Oh, E. No.
I put J.
It is J.
Oh, okay.
On this one, they reflexive, they share an angle.
Okay.
So ACE and BCD, they share this angle up top here. Alright. So J. And then the last part it says hence. ACE, and we shouldn't have wrote congruent there. Should say similar. ACE is similar to triangle BCD due to what? D. Angle similarity. Y'all should see that because we just brought angle similarity on the triangles. Alright, these proofs are not hard. They're just a little bit different. I guarantee you'll be able to do them. Kids in the last class, not last class, they didn't get a chance to. Kids in second period who tried pretty much all got them right. The other two. Do 4 and 5 and we good. We swear. I'm be done with y'all. Thank you for those who participated. Those who didn't, you know how I feel about you.